So drawing the voltaic cell, first of all, you need two beakers, correct?
Yes.
Okay, beaker 1, beaker 2. What's this device at the top? That's my voltmeter. Okay. Now, in beaker, one of the beakers, we need lithium. Okay. So what's the salt going to be? We need a solution. What's it going to be? What's the salt going to be? So the one that wasn't here last week knows what the salt is. Okay?
I don't even remember what I did.
This is the metal. We're connected there. Okay? On the other side, we need a Br solution. Okay? So we need a Br solution, but Br is kind of a gas.
Okay.
So, but we need a solution that has Br in it, so we'll use HBr. But because that's a gas, what's the electrode that we would use?
PT.
You'd use a platinum electrode, which is a catalyst. So you'd use the catalyst in this particular case. Okay? So then we need to connect this with this critter called a salt bridge and
Rainbow.
put KNO3 in our salt bridge. Okay? So that's our picture, okay? Now, in order to figure out kind of the rest of this, E cell and all that stuff, we need to write some half reactions. Okay, so you need to go and write Li is going to go to Li plus 1 electron, and Br2 is going to go to Br minus. But how is it going to do that? You got to add 2 electrons to do that. Okay, so you multiply the top by 2. Okay, so we can find E cell. What's the voltage of the bromine? 1.09. And what's the voltage of the lithium? 3.05. Did we have to? And which one did we have to flip?
Yeah.
They're both.
It's good.
We flipped them. Yeah, they're good the way they are. So then this comes out to be a voltage of 4.14 volts. So that's the E of the cell. Okay, so that's your cell voltage. So, which one of these is the cathode?
Yeah.
Why?
Because it gets the electron.
And gaining of electrons is reduction, and reduction is the cathode, right? So the cathode is over here, which means by default this has to be the anode. Okay, what else do we need to do? Okay, which direction are the electrons going to flow?
Li to Br.
Correct. The electrons are going to flow this direction. That's the flow of electrons. And what direction are the ions going to flow from the salt bridge?
Did we talk about that?
No, but I was hoping you read about it.
No. Well, let me think about this. Okay.
Well, you do need to think about it because you have K plus and NO3 minus as your salt bridge. So what's going to flow in here?
NO3. Yeah.
Yes. The NO3 minus is going to flow there. The K plus is going to flow there.
Oh.
Okay. So I would expect that you can be able to do something like that on your test Friday.
Wait, NO3 flows to Li?
Yes. Okay, so that is pretty much one of your test questions.
Okay.
Okay?
Do we have to draw a picture though?
Yes. What if you draw a picture? Okay, so here's where we're at. Redox reactions occur 2 ways. Okay? The way we talked about last week is through galvanic or voltaic cells. Okay? And when they do that, there's a transfer of electrons through an external circuit that creates a flow of energy. That's a battery. Okay? And we learned last week how to calculate that cell voltage at standard and non-standard conditions. In case you were wondering, that's what we did Friday. We calculated it at non-standard conditions.
I had a bad week last week. Sorry. It's all your fault.
And we checked off a whole bunch of equations last week as well, correct? Okay? Now, to show you one more simulation of this, figure out which one of these it is. Okay, this is a galvanic cell. Okay, so we can pick a metal. It will let me pick a metal. Really? Oh, you worked before? Okay. What metal do you want?
Zinc.
Okay. So if we choose zinc, what solution should we have?
Zinc and other.
We should have a zinc solution. Okay. What metal do we want in the other one?
Silver.
Silver. Okay. So we choose silver. What solution should we have? Silver nitrate. Okay. Then when you turn this on, okay, you can watch what's happening. So what direction is the flow of electrons from?
Zinc to silver.
Yeah, the electrons are flowing from zinc to silver. Look what's happening in the silver beaker. So what's happening to them?
More Ag.
So what do you suppose happened to the mass of that silver metal? The what?
Why would it increase? I don't know. Sorry, I wasn't. No, you're probably right. I just thought that maybe they're just hearing it. I don't know.
Look again. Oh, this one was zinc.
Okay, whatever.
So where are those silver ions going?
Increasing the, oh, they're going into the,
So aren't they depositing onto that piece of silver?
yes,
So what would happen to the mass of the silver?
increase,
It'll increase. What's happening to the mass of the zinc?
decreases.
It will decrease. Why is it negative? Why is it negative?
Why did it want that?
Now why is it positive?
Because you switched, like, which flow direction.
Yeah, that's all we did was switch the flow, the direction. That's all we did. We did this with the metals that we did last week, right?
Yes.
Okay, all I did was switch the sides. Okay, so what type of cell is this? Okay. So now, what we're going to do is talk about using electrical energy to produce a chemical change. So last week we created batteries, so we got energy out. Now we're going to put energy in. This is called electrolysis. And electrolysis uses electrical energy to produce a chemical change. So now you're actually going to force the electrons to go where you want them to go. Okay, so with electrolysis, okay, few things you need. Okay, you got to start with a power supply. Okay, so we got power out last time. Now we're going to put power in. So you actually have to start with a physical power supply. It's not a voltmeter anymore. Voltmeter just measure the voltages. Okay, and then what you're going to do is you are going to need a solution of some type. So to start with, we're just going to have a solution of molten salt. Now, this is different than a water solution of salt. This is like NaCl that's melted. It's not NaCl dissolved in water. Okay, so in here, we have molten NaCl. Okay. Then you're going to have wires connected here from the positive and negative side into the solution. Okay. Now, this is the positive side over here, and you have Na plus ions and you have Cl minus ions in the solution. This is the positive side, that's the negative side. Okay? What's going to go over to this negative side? Na. So the Na is going to, you're supposed to stay. Well, the Na is going to go over here. Okay?
He doesn't want to go.
Apparently he doesn't.
Or he wants to go.
Okay, so the Na migrated over there. Okay? And what's that Na going to pick up when it migrates over there? Yes. Okay? So what's going to happen is there's going to be a transfer of charge in this due to the migration of ions in the solution. So the ions in the solution are going to be able to migrate to the positive and negative charges that are available. So the positive charge is going to migrate to the negative electrode, and the negative charge is going to migrate to the positive electrode. I'm going to put Cl minus over here. Cl minus is going to migrate over here. And all the NAs are going to migrate over here. Okay? So I already answered this question, but what will sodium be able to gain at the negative electrode? Electrons. So I'll have an Na plus ion that's going to gain an electron and become what? Na. So what is that? Oxidation or reduction? Gaining of electrons, GR. Leo the line goes GR. Gain of electrons is reduction, right? Yes. So this is reduction. Okay? So what's going to happen on the other terminal? What will the chlorides do at the positive electrode? What are they going to do? They're going to lose electrons, and it becomes Cl2, which means you need two of these to lose electrons. So what's that? That would be oxidation. Okay, so at this terminal over here, okay, this is oxidation. This is reduction. Okay, and that's what's happening in electrolysis. Okay, so that's one simple electrolysis.
What does this run?
What does it do? I'll show you in a minute. Okay, one of the things it's actually used for is separating water. Electrolysis is how you have to separate water. So, obviously, if we boil water, that's not how we can separate the hydrogen and oxygen molecules. So boiling water at home, adding heat, does not separate the molecules. So in order to separate the molecules for water, you have to use electrolysis. It's the only method that we can use to break hydrogen and oxygen apart.
Oh my god, I can't even spell the word this. I put tis.
That's how they spell it.
Happy Monday.
Happy snow day. Oh my god.
Yeah,
Happy
welcome
joy,
to
joy.
Minnesota.
Thank you.
I said, you didn't like crash on your plane, did you?
You sad you didn't crash?
No.
I'm sad because it's not
Lisa, you
raining.
could have eaten other humans.
Okay.
Crash, yeah.
Appalachian
So
Mountain.
really loud.
There's cannibalism in my Western city. Not
So,
me.
are you drawing this picture or not?
I'm no
Should
artist.
we? That looks really hard.
It's just a beaker with 2 test tubes.
She started laughing. I started laughing because you started laughing. No, you started laughing. No, I didn't. You did. I got a
Okay, so if you're drawing this, okay, it's really a beaker with 2 test tubes,
Okay.
okay?
That looks like a bunny when I draw it. Just when you
How
do.
old are we here?
12. Yeah. 6. It's so cute.
Okay, so these blue things are the test tubes. These things right here, okay, are electrodes that are coming into it. Okay, so the power supply is up here somewhere.
I think a black pen.
So these are electrodes
Black pen.
that are coming into each one of these. Okay, this right here is a little platinum catalyst or some type of catalyst at the end of that. Okay, and the way this kind of works is this statement right here is believe that the water picks up electrons directly. Okay, so it looks like this is the equation. So what happens is the water will gain electrons directly and become hydrogen gas. So at this negative terminal right here, okay, the water is picking up electrons directly, and so filling this is H2 gas.
So the other one's OH?
Okay. And so at the other side, okay, it is also believed that water molecules give up the electrons directly at the anode.
So the first equation is for the hydrogen tube?
Correct.
That
And then
is
the-
spelled hydrogen all weird.
I was wondering how long it would take someone to notice that.
I noticed that. I was like, I didn't realize that.
Oh.
I took it, this picture came off of a foreign website.
Foreign. Don't looking at me.
Classic.
That is not my language, people.
Lies.
Okay, now if you notice this, how does the oxygen gas compare to the hydrogen gas?
It's smaller.
How much?
Twice. Half. It's half the big.
Yes. So there's twice as much hydrogen as there is oxygen?
Yeah.
Okay, what's the balanced equation for this? What's the balanced equation for taking hydrogen or water apart? What would it be? You have H2 plus O2, but what's the balanced equation?
2 H2. No, 2 there.
So there's
Yeah.
twice as much of this as there is oxygen,
Yeah.
which is what will happen.
Cool.
Okay? Gas-wise, you'll get twice as much hydrogen as you will oxygen out of this. So if we take these two half reactions, oh, by the way, this should have been a 2 here. Oh, what was this? I forgot that. And there should have been a 2 there. Okay. So if we take these two half reactions and we add them together, before we add them together, we're going to have to balance the electrons. So I forgot this initially. Up here, these should have been a 2 and a 2 way back up there. So this should right now be 2 H2O plus 2 electrons gives me that. Okay, so yeah, what I need to do is balance my electrons, so I need to multiply this one by 2. So that would give me 4, 4, 2, and 4. Okay, so now when I add these two together, the 4 electrons go away. Okay, I have 4 H2Os plus an H2O gives me, so I have 5 H2Os. Yields 2H2 plus O2 plus
4H3O.
and what is that? Be careful. You have H3O plus OH minus gives you 2 H2Os. Okay? So these two together are going to give you 8 H2Os. Oh, shoot. I lied. This should have been a 2 right here, too. Because this has to be a 6.
I didn't do this again. I did.
Okay, so now, when you combine your H2Os, you have 2, because these can come over here, you'll have 2 H2Os give you 2H2 plus O2, which is our balanced equation.
Why is it?
Why is it
that?
How'd that happen?
How did I pull that?
Wouldn't you have to take away from the 6 and
Yeah,
have
if you're
2
gonna
on the
take
other
away.
side?
Yeah, but it's got to work out this way. So
Whoa. Well, what the crap?
A3O, we use H plus.
I should have been doing this in all my assignments, but it just happens
It
this
just
way.
happens
Live
this
with
way.
it.
Oh my gosh.
yeah.
I don't know what happened.
Wow, okay, I'm royally messed up now.
Well, we got to get this when we're done. So.
We'll
Okay.
figure it out later.
So it's like calculus. It's not
Yeah.
math.
As long as you get the right
Well,
answer.
Tessa and Calc, she manages to get the right answer in a completely opposite way of what we
Really?
were taught.
Okay. So let's talk about electrolysis with a specific electrode. With a specific electrode.
I could never.
This is electroplating.
Right.
So you're asking, what use is this? If you have gold-plated jewelry, this is the process that's used for that. Most of your sinks and things in your home are plated with chrome.
How much does this cost?
Our sinks in our shed right now.
What?
That's because you're a hillbilly. So.
Rednecks.
Rednecks.
It's true though.
Oh, well.
My mom ate ice cream out of a cup last night.
How?
Dude, I do it all the time.
I feel
Actually, last night I had
Okay. So what we're going to do is we're going to do an electrolysis, but when you want to gold plate something or silver plate something or chrome plate something, okay, what happens is the electrodes actually are a part of the process. Okay, so you're going to start with the same type of container that we had when we started with sodium chloride. So, but you have to, first of all, start with a solution of salt that contains the ions that you want to deposit.
You want to write that down?
Yeah, you do. So what we're going to do is we're going to silver plate something. So we're going to plate something with silver. So that means what ions do I need to have in the solution? So I need silver ions.
Can you use any salt?
Right, I can use any salt that will dissolve. So any salt that has silver that will dissolve. So what would be a good salt that has silver that will dissolve? Yes, silver nitrate. So this is a silver nitrate solution.
God, I can't write that fast.
Okay. And then you need a metal that is the same as the ion. So I need a piece of silver metal. Okay, now, where am I going to put that silver metal? On the positive side or the negative side?
Positive.
I'm going to put it on the positive side. So over on this side, I am going to have a chunk of silver. So this is solid silver. It's a piece of silver metal that's over here. Okay, now,
That's whatever metal.
over on this side is whatever I want to plate. So let's say I want to silver plate a spoon. 'Cause some of you were born with a silver spoon in your mouth.
You should take Miss
What's her
Kennedy's
name?
job.
What's that
You're a
saying?
good artist.
Explain what's that saying?
Why are
You were
saying
born.
that? What's
You
the-
never heard that? You're born with a silver spoon in your mouth?
I've never heard that.
Come on, Becky.
Okay.
What does it mean?
What is it?
Just, I need a clarification, so you two stop laughing over there. How many people have heard you're born with a silver spoon in your mouth?
Not me.
Only the foreign.
That's awesome.
Yeah, but she's never seen a white Christmas. It doesn't count.
No.
Goodness.
That's completely irrelevant, but it still doesn't count.
Do you want to explain to them?
Is it like they have a great opportunities ever since they were born, kind of like that? They have riches.
They have riches, yes.
Yeah.
You're
Spoiled.
basically you're a spoiled brat.
Well, I knew I
You're-
should be
you're born-
offended, but I didn't know why.
Basically means you're a spoiled brat, yes. So now, when this is turned on, okay, what is going to happen over at this negative side? Well, this is negative, correct?
Oh yeah.
And the silver is positive, correct?
Yes.
So the silver is going to migrate over to that metal side. And what is the silver going to pick up?
What?
Electron.
It'll pick up an electron, and it will become solid silver.
No.
Okay, what's happening over here? Why did I have to put this solid piece of silver in here?
It's the other way around.
Yeah.
So this is putting more silver back into the solution. Okay? So what's happening on the other side is the solid silver is losing an electron and becoming silver ions. Okay? So the cathode, what's that?
The spoon's losing it?
No.
Spoon wants to get that metal on.
This
Oh, okay.
this is
I got
the
it.
spoon.
I got it.
I feel like I should have drawn a plate on a spoon.
Would have been easier.
So, the cathode is the object you want to be plated. The cathode is the object you want to be plated. This is where the reduction occurs. The anode will be the metal you are plating with. It will undergo oxidation.
Alright, hold on. I can't write that fast.
I have a question. So like for electrolysis and electroplating,
Yeah.
the cathode is like the negative one, but like it's the other way around for sulfate.
My arm is cramping.
was waiting for someone to figure that out.
What?
I'm sorry.
Yeah.
It's probably best I leave it for now. Okay, got this? We're gonna watch a little video on electroplating. Okay, forgive this guy at the beginning, he's a dork.
Oh, you made a video?
Oh my god.
Is
Is
it
it
Bill
Bill
Nye?
No, it's not Bill Nye.
No, it's not.
Against what? White people?
Okay, watch.
Chromium.
Oh, wait.
Wow, who would have thought it would come down to chromium? It's another one of the transition metals. But, you know, strangely, it's time
Yes,
out
cute.
for, with actually essentials for our diet as a trace element. That's a hexavalent form. Almost deadly. But for a metal, sure makes my house finish.
Chrome, copper, brass, nickel, zinc, tin, silver and gold. Objects made from these metals seem to be everywhere. But in most cases, the metal on the outside of these items is just that, only on the very outside. It's put there by electroplaters like us. Hi, I'm Rob Blake from Precision Plating, and I'm going to show you how. Electroplating, or coating an item with a thin layer of metal, involves dipping an object that can conduct electricity into a solution that has dissolved metal in it, and passing an electrical current through both of them. The current causes the object to become negatively charged, while the metal ions in the solution are positively charged, so they're attracted to each other and the metal deposits on the object. But why put a layer of metal on an object at all? What is the point of electroplating? Well, it can give an item a desired property, like resistance to abrasion, protection against corrosion, or a certain visually attractive finish. So what sort of objects can we coat? Those made from a large range of metals and a few types of plastics, but because everything we dip into solution must be able to conduct electricity, plastic items must first undergo pre-treatment before their surface will carry a current. To pre-treat plastic parts, we first have to process them through 4 different solutions. Each of these solutions will treat the surface in a different way without the use of electricity. The first solution is acidic. It etches the plastic so the layers we add on top afterwards will bind to it properly. The second and third solutions give the plastic parts an even coating of atoms of the metal palladium. And these allow the final pre-treatment layer of electrolysis nickel to grow on top. The metal-coated plastic parts can now conduct electricity and be electroplated in the same way as metal parts. Now, electroplating itself isn't a one-step process either, as most metal finishes require other metals as undercoats. For example, to achieve a chrome finish on a part, you first need to coat it with copper and then nickel. The copper layer makes the surface bright and level, and the nickel protects the copper and provides corrosion resistance. The same undercoats are required for parts with gold and silver finishes, so we add them more often than not. With all overcoat metals having bright and satin variations, and some having colour variations too, the range of finishes an electroplated product can have is huge. They're used in bathrooms, kitchens and sheds, offices, shops and art galleries and on planes, trains, boats and cars. Now you know a bit about how electroplated items are made, you'll probably start seeing them everywhere you look.
Over the years, car enthusiasts have relied on premium-grade Brazilian carnauba to keep their cars' finish looking sharp.
I wanted to see how to get clothes inside.
You can do this at home.
It's a super simple way to do nickel electroplating. Before I electroplate my item, I like to make a little nickel bath here. The water is very warm. It actually started out as boiling water. Inside of here, I have a solution which is just pure tap water with nickel ammonium sulfate, and I mixed 1 quart of tap water to 3 ounces of nickel ammonium sulfate. And I like to test it before I do my actual item. So what I'm going to do here is I'm just going to take a penny, nice shiny penny, and I went ahead and I cleaned that penny up. And I used a little vinegar when I cleaned it. That works real well with copper. And I'm going to set it into the bath here. And as you can see, I'll go ahead and I'll let that stick out a bit. As you can see, I have 2 batteries, just a couple of D cells. Everybody I know that does these nickel plates always uses things that plug into the wall as far as something like 12 volts, something like that, very high amperage to bring it across. I've had long-term bad results anytime I used anything other than a very small amount of electricity for this. And check this out. This was only a couple of seconds, and look at that. We've already got a nickel plate starting, so it's getting shiny. Now with nickel, when you nickel plate something like copper, steel plates really well as well. And when you nickel plate it, it's really looking shiny and good. It'll be a bit dull until we buff it later. And this test already looks to me like we're going to have a really good plate. Now over here on this side, connected to the positive terminal of the battery, is a plate which is pure nickel. So we're using that as our anode. And then our cathode over here is going to be the item that we wish to plate. And actually, probably with the water, especially with the water being hot, this is only going to take a few minutes. Another thing, you might want to have a stirrer. Most nickel baths I've seen have some kind of a mechanical stirrer. If you're doing a lot of nickel plating, look at that. It's really getting a good shine on it. Put it back in.
Yeah.
So a lot of that stir, because for some reason it does seem that the crystals do fall out of solution after a bit. And that's all there is to it. We'll leave that for just a few minutes, and we're going to wind up, I hope, with a nickel-plated penny. So I'll go ahead and shut the camera down for a few moments. You're really neat about using these low voltages and just taking your time to plate it. You don't really get any bubbling in the solution. And your piece comes out.
Wow.
Check this out. Look at that perfect, shiny nickel finish on the whole penny. You also would normally use an alligator clip. Pretty much just set it on anything conductive and cradle it, anything conductive. I use the alligator clip here, and I just moved it once so that the spot where the alligator clip was holding will also be plated. But this will require almost no buffing at all. And our test is complete. This is going to work fantastic.
Like, it's stupid that it has a word. Yeah. Like, I'm gonna use this.
Finally comes out of the bag. Copper.
I would save on it.
Those pennies are really old.
Yeah, I was gonna say.
Yeah.
But, oops.
Whose feet is it?
There's a branch here.
We're not doing nothing. We ain't doing nothing in here.
okay, so draw an electrolytic cell for gold plating a necklace. Go. What?
Gold plating.
Different language.
This is what I
I
emailed
have
Dana
to
asked
process
you to do.
that.
Oh, yeah, do.
Process the English.
Don't worry about it. I don't think that. This. Okay?
When?
Today.
Okay, you get it after school.
At 1:30?
After school?
I won't be here. I'm
Well, I
going
can't do it by 1:30. What is this for? Oh,
cleaning.
great.
So I'll probably send it in the morning if you get them.
I'll get it done. It's not right now. We're drawing an electrolytic cell. Why don't you draw one with us?
What's the charge?
+3.
Oh, really?
In this case, it'll be +1 or +3, whatever way you want.
No way, Lisa.
It's beautiful out.
Look
It's
at
shorts
that.
weather. Lisa, it's dress weather for you. Are you kidding me?
I thought we were in the drizzle section.
Drizzle.
I heard it's supposed to be 71.
So this is what it feels like to live in Alaska.
So
No
for-
happiness.
Except for half the year it's dark and the other half the year it's bright.
It doesn't suck. It never is dark out.
I would sleep. I would trip
That's
me up
depressing.
so bad.
Like, I love a good
I would
breakfast.
sleep like 5.
Well, because I bet you had the hours.
Yeah, it's just an hour.
Oh, it's like 12 hours.
My sister had an 18-hour flight.
I saw how big that elephant was.
Okay, so do you have this drawn? Okay, so you have a container drawn?
Yeah.
Okay, you have a power supply drawn.
Yes.
Okay, what side did you put negative and positive on? Negative, positive. Okay, you have a solution, correct? Okay, so we are gold plating a necklace. So what is in the solution? AU plus 3, is that what you're using? Okay, and it's probably AuNO33. Okay, so what side is the necklace going on? Okay, so over here you have your necklace.
Creative.
Okay, and then over here you have what?
Gold.
You have a solid piece of gold.
Yeah, me too. Like, why would I do this?
Why would I be playing with it? But if you buy gold-plated jewelry, this is what they've done to it.
Okay.
It's obviously cheaper. No.
Oh.
If you're going to buy a gold-plated necklace, it will be cheaper than a solid gold necklace.
So I'm trying to tell you, if you really love someone, you'll get them like a chunk of gold and then just like melt it onto a ring and not make anything out of it.
Sure, Vicky.
Could I gold plate my grill? I would end up.
Yes, you could gold-plate your grill if you
Or
wanted to.
grill in your car, like you grill the.
Oh, okay, so what side is the cathode?
There.
This is the cathode?
Yeah.
And so by default, this is the anode?
Yeah.
Okay, good. Now you know how to gold plate it.
The cat is angry, so it's always going to be the negative side. Grumpy cat. It's not the pussy cat anymore. No,
The
it's
what?
The grumpy cat.
It's the
Tartar sauce.
pud.
It's tartar sauce.
Oh my gosh, you guys.
I don't know how they got the
Me neither.
You guys don't know who tartar sauce is?
I do.
Well, then how do you not get this?
I don't know.
Why are you so stupid?
Okay, so let's count electrons. Okay, so we're going to count the flow of electrons. Okay, so counting electrons we already know how to do. That's Avogadro's number. Okay, it is just the number of electrons that are transferred in half reactions, which you did Friday. So the number of electrons are transferred. Okay, good?
We don't even write this, do we?
No.
Great.
Okay, what happens is, okay, we're going to deal with the flow of electrons. Okay, we said the flow of electrons was called something last week. What was it?
Current.
Give me a chance.
So the flow of electrons is current. We use the symbol I for current. Current is the number of electrons that flow per second. Beck?
I just had an epiphany. You know how Catherine was negative? What's my mother's name?
Kathy.
Oh! God, I'm a genius.
Does it smell like what's in it?
Okay, so current is the number of electrons flowing per second. What was the symbol last week that we used for electrons?
Yeah, I know.
Q.
Oh.
Remember, Q was charge. And what was the unit of charge?
C.
That's the letter that C stands for Coulomb.
Yes, I got something right.
Okay, so we have coulombs of charge, okay, divided by how much time that charge flows. So T is time. Okay, so the unit of current is coulombs per second. What's a coulomb per second called? Yes, we talked about this last week. That's why I'm frustrated. No. You were
I
here the
had
day
it
we
bad
did
or
this.
weak last week, so I have to drink my student.
Oh, yeah. No, it wasn't.
How fair. Or I was going Friday.
Yeah,
Coulomb
she's
per
getting her
second
nails
is an
done.
amp.
What? Where did we? Oh, I put it in another note.
Okay? So if you have 1 coulomb per second flowing, you have 1 amp of current. Do you remember what 1 coulomb was?
Oh.
6.234 times 10 to the.
Oh, what?
1 coulomb of charge is 6.24 times 10 to the 18th electrons. So if you have 1 amp of current, how many electrons are flowing per second?
Six number.
That number. Okay? Do you remember a Faraday?
Faraday's constant. 996,500. Is that right?
Yeah.
Yes.
Huh?
So a Faraday was 96,500 coulombs.
Oh, we're getting out, guys.
Good afternoon. We will be dismissing
Holy
after
crap!
the end of this hour today.
Ah!
For the 6th hour. Once again, you're dismissed at the end of this hour today. As a reminder, there are no activities or practice today, and please be careful on your trip home. Thank you.
Yeah, I always
I don't
sit.
even have anything 6 and 7
I always
hours.
sit and wait in the parking lot for like 10 minutes and watch everyone get in their accidents.
freak out.
Okay, write this down.
Okay, I'm gonna run out. Okay.
Oh,
I'm
jeez.
Can I just steal your thing if you Oh, yeah.
I just had.
No, you need to get done with last
That
one.
is no point except for.
Okay, unless I can get this done in 60 seconds or less. Okay,
I love snow.
what we're going to do is figure out what
Bipolar.
mass is actually deposited when we electroplate
Should be
something.
through a solution.
A current of 1.5 amps is passed through a solution of silver ions for 15 minutes. And I want to know what mass in grams of silver metal is deposited, because you don't want to just electroplate forever, because you will get a very heavy object. Okay, this is what I was asking you earlier when we said, does the mass change when you're electroplating? And it does. So when you're electroplating something like gold or silver, an expensive metal, you don't want to electroplate forever, because it will get more metal on it than you want. So we want to know what mass in grams will be deposited when we do this. So there are about 4 steps to solving this. Okay, step number 1 is you want to find the amount of charge that you're actually dealing with.
Wait, is this an example?
Yes.
I said, excuse me.
Where are you guys at? Are you on my step 1 or are you still writing?
I'm on step 1.
Okay, so that's where we're going to use the current equation. Current is charge divided by time. Okay, well, if I want to find the amount of charge, which variable is that?
What?
Which
What
variable?
does time have to be in? Doesn't matter.
I
what
guess
time.
like 1.5. Yeah, amps.
So to find the amount of charge, charge is Q, correct?
Yeah.
So Q is equal to current times time, just solving the equation, correct? Okay?
Keep it in minutes or seconds?
You're going to have to change it to seconds. Because current is 1.5 amps, but what's an amp?
That is
It's a coulomb per second. So I cannot multiply this by 15 minutes.
Okay.
So I have to do a quick side calculation. 15 minutes times 60 seconds per minute is what? So that's 900 seconds. So that's how you get your seconds to cancel. So how much charge do we have? 1,350 what? No.
Oh, shoot.
It's now coulombs. Okay? Step 2 is you need to find the moles of charge that you have. Okay? This is where you use Faraday's constant. Faraday's constant says 1 mole of electrons is 96.5 coulombs. So how would I use that to find out how many moles?
Divide that, or times it by 96. No. Divide it. So
No.
Convert it.
Yeah.
This is basically just a conversion.
I hear that.
Me too.
I did too.
Dang it.
Why didn't I hear it? What is it?
0.014.
And what would that be unit-wise now? Moles of electrons. Okay? Now, this is silver, so we'll pick it up here.
Wait, can you scroll back down?
Multiply that with molar mass of silver.
And iron.
Lisa, we're done with class. Stop talking.
I was already done anyway.
Yeah.
Storm gets worse.
I can't remember, did she say
Why
go to fifth, sixth
She
hour?
said, yeah, she said to check in.
I have to go to 6th hour.
No, I'm not doing it.